Welcome back, Deep Divers. Today, we're diving headfirst into a topic that sounds like it's straight out of Star Trek quantum teleportation.
Yeah, it's funny you should say that because for a lot of people, it does seem like science fiction.
Right. But the reality is, this is happening in labs right now.
It is. It's real deal science.
Hmm.
And it all comes down to something even weirder, entanglement.
Okay, so before we actually teleport anything, I think we need to take a step back and define what we're talking about.
Yes.
When we say quantum teleportation, we're not beaming people or objects from one place to another like in the movies.
Not quite. No.
So what are we teleporting then?
Well, think of it this way. Imagine sending a recipe for a cake instead of sending the actual cake itself.
Okay.
The person on the other end, they get all the information they need to recreate that cake down to the last sprinkle, right?
Yeah.
That's kind of like quantum teleportation. We're teleporting the information, the quantum state of a particle.
Oh, okay. So we're not dealing with matter, we're dealing with information.
Exactly. It's a bit more abstract than a cake,
Right.
but it's a good analogy.
So if we're sending a quantum recipe, what are the ingredients? What do we need for this to work?
Well, we need three main things. First up, we've got our entangled particles.
Okay, entanglement. That always sounds so mysterious.
It is. These are like two particles that are linked, but in a way that even Einstein called, spooky action at a distance. It's like they're connected no matter how far apart they are.
So you measure one and it instantly affects the other.
Boom, instant effect. It's mind-blowing, really.
I have to admit that is pretty spooky. All right, so we've got our spooky entangled pair.
Right.
What's next?
Next, we need to prep the quantum state that we actually want to send. This could be, I don't know, the state of a photon, an atom, anything that has those quantum properties.
So like choosing what kind of cake we want to teleport.
Exactly.
You got it.
Okay, so we've chosen our cake. We've got our spooky entangled pair ready to go.
All right.
What's the next step in our recipe? Now, this is where it gets really interesting because, you see, we can't just copy a quantum state.
We can't.
Nope. There's a rule. It's like a fundamental law in quantum mechanics called the no cloning theorem.
So no copy-paste in the quantum world.
Exactly. It's impossible. And the reason is, imagine trying to, I don't know, photocopy a dollar bill that's constantly changing its value.
Oh, okay, I see where you're going with this.
Right. Like, you could try to capture a snapshot, but the original is always shifting.
Ah, so teleportation isn't copying at all. It's more like a transfer.
You got it. It's like a transfer of that state. And, get this, the original state is destroyed in the process.
Whoa, wait a minute.
So there's only ever one copy. It's like the ultimate disappearing act.
Wow. Okay, that is way more complex than I initially thought.
Yeah, it is. It takes a minute to wrap your head around it.
I think we need to go through the actual steps of teleportation, like a play-by-play.